Welcome to the CPD webinar on the topic of water quality. Today, I'm delighted to welcome our guest speaker, Joe Bradley from the Environment Agency, who will be talking on the topic of risks and opportunities with sustainable drainage systems. My name is Peter Coombs, and I'm the Vice President for Business Development in the area of EMEA. And Joe Bradley has been with the Environment Agency for over 25 years, involved in aspects of water quality. So very well qualified to provide a presentation for us now. So without further ado, I'll hand you over to Joe on the topic of water quality, risks and opportunities with sustainable drainage systems.
My name is Joe Bradley. I work for the Environment Agency up in Preston in Lancashire. I'm very grateful for this opportunity to talk to all sorts of people all over the place, which is rather exciting. I've been doing pollution prevention for about 25 years, which makes me feel old. I have been doing water quality advice for most of that time, so that's why I'm here to talk about the opportunities and risks associated with SuDS, particularly for water quality. So for me, the most important aspect of SuDS and water quality is the impact of the stormwater runoff and the water pollution. So stormwater runoff can range for all sorts of things, from clean roof runoff, which is usually lovely, to road runoff or industrial estate runoff, or runoff from a petrol filling station or a supermarket car park, for example, which is not lovely. So probably the most important message I'd like you all to take away from today is that not all stormwater runoff is equal. I get a lot of conversations where people talk about SuDS and stormwater runoff and the opportunities to discharge stormwater runoff to ground. And people forget that not all stormwater runoff is the same. So when you design a SuDS scheme for a site, say it's a hospital or a school or a residential development, you need to think about the different pockets of that site and which pockets of the site are particularly polluted. So you may have a small area which is particularly busy or has a specific activity taking place that causes all sorts of nasty pollution. And the trick is to keep that area as small as possible and to deal with that pollution as close to that area as you can. As soon as you start conveying that dirty water down the system and adding more water to it, then it simply increases in volume and becomes more and more difficult to treat. So if you think about a linear road development, for example, if you can treat every linear metre of road with a linear metre of treatment device at the side of the road, like a filter drain or a swale, then the flow rate into that linear treatment and filter device is quite low. It might only be 6 or 10 litres per second. But if you take half a kilometre of that road and drain it all down the hill to one outfall pipe at the bottom of the hill, you might be looking at 175, 180 litres per second, and it suddenly becomes much, much more difficult to treat. So the trick is to find that pollution, keep it small and treat it close to source. There's some data here that I'm going to show. There's 2 columns of data. The column on your left is from a small residential development in a little town called Padiham. I took these samples probably about 6 years ago now. We did 7 rainfall events, and you can see there from the average results of 7 rainfall events that the pollutant load is quite low. The water is still polluted, so you can't say that that's clean, uncontaminated surface water. It is still polluted, but actually the pollutant levels are quite low. You've probably got less than 300 vehicle movements every day on that little residential development, and it just discharges into the neighbouring river. So one level of treatment, a good vegetative treatment device, might be all you need on that site to allow that water then to discharge to the water environment. On the right-hand side, you've got the results from a really busy arterial route into Preston. So this goes up the hill into Preston town centre by the prison, for anybody who knows the area. And it's congested every morning, it's congested every evening. And there's about 36,000 vehicles a day going up and down that hill. So if you compare that with certainly less than 300 vehicles a day on that other road, 36,000 on the London road going into Preston. So you look at the data there and the difference in those results, and those are massively more polluted. That's average results over 4 rainfall events. We've taken those recently, took those with a colleague of mine, Lancashire County Council, a chap called Robert. Thank you very much to him for allowing me to share this data. And we've worked together to look at this data to try and understand what the impact of road runoff is on that river. So massive pollutant levels there, 715 micrograms per litre of zinc, and 353 milligrams per litre of suspended solids. The suspended solids for me is a massive problem because that's contaminated sediment going into the river environment every time it rains. And you're talking about kilograms of solids there, so probably, I don't know, 20, 25, up to 50 kilograms of solids in one rainfall event. So a significant pollution event every time it rains. The reason that worries me, I suppose, and the reason I wanted to talk to you today is that there's quite a big shift. I've seen quite a big shift over the last few years to talking in the sort of SuDS community about interception. And for purposes of water quality, that really, for interception, read infiltration. And that's fine where the risk is low. That's fine on a residential development where the water isn't very polluted, or for roof runoff where the water isn't very polluted. But it's not always acceptable. It isn't always possible to put the water into the ground. If the pollutants are low, then a vegetative SuDS scheme will deal very beautifully with that. The pollutants will break down in there, so you've got microorganisms, you've got the sunshine and the wind and the rain and the vegetation all acting together to break down the pollutants, and that's fine. But some of those pollutants will not break down, and we really need to start remembering that. We talk about interception for water because as the water runs off a site, you can stop it. So you can either stick it in a rainwater harvesting tank, or you can divert it into an attenuation vessel, or better still, you can put it into a vegetative treatment device or a swale or a filter drain. And that water will never leave that site in the surface water drainage system. So you won't see water rushing off the site into the river. So you've basically stopped it. It almost disappears because it evapotranspires. But the pollutants aren't made to magically disappear. The pollutants aren't stopped. They're simply redirected somewhere else. So those pollutants were going to rush off the site and go into the river, but because of the way you've designed the SuDS scheme, those pollutants are now moving and they're going to go either into a vessel or into the ground. And you really need to think about that because some of those pollutants are toxic and persistent and elemental. They're not going to disappear, they're not going to break down, they are simply going to move from one water environment to another. And when you put them into a ground environment, into a soil environment, or bioremediation zone, or a tree pit, or a swale, there's a finite capacity for that device to cope with those elemental pollutants and those persistent pollutants. It isn't simply a never-ending opportunity to dispose of pollutants. There's a finite capacity to that. I like this picture, and in fact I'm going to try and fiddle with my mouse and I hope you can see. This is a very small infiltration basin, and I mean very small. It's possibly the world's smallest infiltration basin. So the basin's there. It's just a little depression in the land. And this is in our car park in our office at Preston. And there's about 10 car parking spaces here where I'm sitting. And then the water runs down, and you can see that it was designed to go through these spaces in the curbstones, pass down into this basin, and then just pull nicely and then infiltrate into the ground. It's not perfectly designed because you can see that it preferentially comes to this space here and passes through, and we've got a little bit of deposition there of contaminated sediments. But at the end of the day, it runs into that little depression, it creates a little pool here, and then over the next couple of days it disappears into the ground, it infiltrates into the ground. And I've never seen it overflow. This is a stream here, and I've never seen it overflow into the stream. So it's tiny, and it treats a really small part of our car park, but it's absolutely lovely. It's a beautiful example of a SuDS device that wasn't very expensive. In fact, it was probably cheaper than putting the pipe system into the local surface water sewer. And it's aesthetically, it's quite pleasing, and it needs very little maintenance. We just mow it at the same time as we mow the rest of the site. The question, I suppose, is that acceptable? It's very low risk. It's a fairly low turnover car park. People come to work and then they go home and tend to stay parked up all day. A lot of them are leased cars and pool cars, so they're well maintained and they're well looked after. And the question is, does that matter? Is that acceptable? Will that soil be able to carry on taking that pollution 50 years or 100 years or forever? And the truth is we don't know. And that particular example, I think, is very low risk. I don't think we need to worry too much about our car park. We do need to think about it for higher risk sites. So if you're designing an infiltration device for something that's higher risk, so road runoff or an industrial estate discharge or a supermarket car park, you really need to recognise that finite capacity to retain and capture the pollutants and consider, if I'm building a bioremediation zone and it has a design life of, 100 years or maybe 10 years, 25 years, it depends on the pollutant load, you need to make sure that somebody records that and recognises that and maintains that information. Because if you leave or change companies and the file that you wrote that down in is lost, and the chap that you told it to and the lady who was sitting next to you have all forgotten, then who's going to make sure that in 25 years' time somebody comes back and empties that bioremediation zone and regenerates the media and replaces the plants? It's a significant risk, and I was thinking about it as I wrote this, and I'm not sure how you maintain that sort of perpetuity of information. I think perhaps the best solution is just to stick a sign up and say this is a detention basin. It will need checking and possibly scraping and regenerating in 50 years' time. Because I'm not sure how we do that, but it's absolutely essential that we recognise that there is a risk that in a few years' time, the capacity of that soil, an unsaturated zone perhaps, to retain those pollutants will be exhausted, and the pollutants will then start to move, and we need to recognise it. So about, 6 months ago, I was doing a presentation, something similar to this, and I thought, I need a photograph of the detention basin. I know where there is one, I'll go and take a photo. And I remember this being built, I think about 15 years ago, and it was newly seeded, rather nice grassy depression with a little drainage channel down the middle and an inlet and out. It was one of the early SuDS schemes in Preston, so we were all rather excited. Went and had a look at it and found this. And it was beautiful. There were birds and dragonflies and butterflies, and the sun was shining again. I always go out in the sunshine. And I mean, look at that. There are mature willow trees in there. And it's created the most beautiful habitat. But I wonder what the designer designed. I wonder if the designer designed his design capacity for that detention basin, allowing for that amount of vegetation. I wonder if it was lined to protect underlying groundwater and that liner has been penetrated by those trees. I also worry that, I had trouble finding it. I knew it was there. Who's to say that in another 15, 20 years' time, somebody might not come along and go, there's a public green open space, let's build a netball court or a football pitch, and just completely eradicate that detention basin. And yet it's an integral part of the drainage network for that residential development. It was part of the exceedance flow drainage network. There's another one near here, exactly the same, huge detention basin, part of the drainage network, and now it just looks like a little wetted woodland. It's rather nice. But it's a worry for me that was designed properly, I imagine. It was designed understanding the pollutant load that was going to go into that system. The capability, capacity of that drainage network was calculated, and yet whoever designed it has no doubt moved on to the next job. Whoever built it has certainly moved on to the next job, and it's just been left completely unmaintained, and it's a worry. I suppose the reason I lie awake at night and worry about this is about groundwater protection, because if you've designed a scheme that adequately protects groundwater because you've understood the retention and capture capability of your SuDS device, and you've understood the pollutant load, and you've worked out that the priority pollutants will be retained in your bioremediation zone or your swale or whatever, and that the underlying groundwater is safe, then if that maintenance is necessary and it doesn't take place, then how long is the groundwater safe for? It causes me some concern. We're lucky in the United Kingdom that we don't use all our groundwater. We're not completely reliant on our groundwater. But we need to protect it all, because there will come a time in, 50 years, 100 years, when we really do need that groundwater for public water supply. We're lucky in Lancashire. We have a huge, huge sandstone aquifer under our feet. We use a tiny, tiny proportion of it. But it reassures me that, as climate change kicks in and we become water scarcity becomes more of a problem, we have those resources available to us. But we won't if we're not careful about SuDS design as SuDS picks up pace and starts to get more and more popular in the next few years. So I would argue that it's not good enough to discharge untreated road runoff to ground without adequate pre-treatment. I'll show you in a minute a picture to sort of illustrate why. But I really think as SuDS designers, as I think many of you are, we really need to worry about, is this device going to work now, but is it also going to work in the future? And is it going to work to protect the underlying groundwater? We need to be sure that the persistent pollutants, the polyaromatic hydrocarbons, the herbicides, the pesticides, the things that are poisonous, aren't going into that device, down through the bottom of the device, into the unsaturated zone, and then ultimately down into the underlying groundwater. So we really need to think long and hard about this. This is the right-hand column of data that I showed you right at the beginning of the talk. And this is a photograph of that runoff. So the bottle on the left is just the runoff sample. The little bottle in the middle is just a subsample for metals analysis. And the bottle on the right is that's been filtered through a 45 micron filter. And actually it looks rather nice. But don't forget that the filtered metals in there, you've still got in that little bottle on the right 87 micrograms per litre of zinc and 51 micrograms per litre of copper. So although it looks a lot better, and it is a lot better, the water environment's more able to deal with that, it's still grossly polluted. You know, that bottle on the left is grossly polluted water. We talk about clean, uncontaminated surface water when we talk about surface runoff. But I promise you that is not clean, uncontaminated surface water. And that's the sort of thing that if I see that discharging into a river, that would be a pollution investigation. It is polluted water. Now, in that situation, that's going into the River Ribble, which I don't know if you're familiar with the Ribble. It's a big tidal river at this point, just upstream, but we're only shortly upstream the estuary here. So probably the river has the capacity to deal with a level of pollution. But what if that were discharging into a little stream at the bottom of your garden, or into a little pond, heaven forbid, at the bottom of your garden? Then you would really have a significant pollution problem on your hands. It is a concern. But our knight in shining armour, if you like, the good thing about all this is that in the UK, certainly, which I'm familiar with, but I'm sure across the world, we've got SuDS devices. We've got excellent SuDS devices. The Serious SuDS manual is about to be republished in the next couple of months, and then that's everybody's, it's the go-to guide for designing SuDS. And in there, you've got information on ponds, basins, swales, vortex grit separators, other proprietary products, filter drains, treatment channels, all sorts of innovative and new devices that are fantastic for low-risk runoff, so surface runoff from what I consider a low-risk site. Those devices are absolutely fantastic, and I'll show you a picture in a minute. And just remember that sometimes they might not be good enough, and sometimes I think we haven't got all the treatment devices that we need. But on a low-risk site, imagine a pedestrian shopping centre or a school playground or a residential area like the one I showed right at the beginning in Padiham. Those can be easily treated with a really good SuDS design. This is in Chorley, which is in Lancashire. It's a familiar site to a lot of people who work with SuDS. But this is a residential development. It's a huge development, actually, but this particular treatment device only takes a small part of the development. So residential area, low risk, low traffic densities, pedestrian access around the pond, but that treatment wetland runs into a pond and just does the most magnificent job of treating that surface runoff. And it's beautiful. There's, again, you've got butterflies and dragonflies and bird life, and there were some ducks. When I went to take this photograph, there were some ducks, and the children were feeding their ducks on the way home from school. You can't see it from here, but the inlet structure is a bit ugly, big concrete inlet structure, but never mind, can't have everything. But that's just beautiful. That's exactly what we want to see with a good SuDS design. And that's low risk, so that may carry on doing that job in perpetuity with very little maintenance. But just stop and think what would happen if you put that high-risk runoff into a device like that with your 350 milligrams per litre of suspended solids and 700 micrograms per litre of zinc. A natural habitat like that we've created cannot tolerate those sorts of levels of pollution. I've recently had a couple of telephone conversations with colleagues around the country. One lady who's trying to work out how to get the contaminated sediment out of a lake that's been taking road runoff for a long time, and she's looking at a cost of about £2 million. And then I had another conversation the other day with somebody who's equally looking at taking mixed urban runoff, contaminated sediment from mixed urban runoff out of a lake, and that's got motorway drainage and industrial estate drainage going into it, and they're looking for £4 million. Not only do you create a habitat like that, and then 20 years later you need to find £4 million to clean it out, but just imagine if you were to come in there with diggers now and start desilting that habitat. There's a massive impact on wildlife. And the local residents are probably going to smell. So if you're going to create a habitat like that, which is just beautiful, and is a marvellous SuDS device and does exactly what we want SuDS to do, then please consider how do we deal with the pollutants upstream? How do we stop pollutants from causing pollution of the habitat we've created? This is a device we installed in Wigan. This is a vortex grit separator, but it could equally be a full retention oil water separator or a grit removal device of some sort. But if you put something like this upstream of your vegetative habitat that you're going to create, this will take a proportion of the contaminated solids out. So this will take some of that contaminated suspended solids, not all of it, a proportion of it. And then every 6 months or every 4 months, you come along with your vacuum tank or your gully sucker and you take out the contamination from there. So that might cost several £100 a year, but that's better for everybody. It's better for the environment, and because that's not going on into that natural environment. And actually, it's better for the revenue costs of whoever owns it to face a bill of a few £100 a year rather than every 20 or 50 years having to find millions of pounds. And it just protects the habitat we've created from that gross pollution. And I just think if you're creating a pond or a detention basin or some sort of standing water habitat, the last thing you want to do is pollute it. So just stop and think about that 350 milligrams per litre of suspended solids and ask yourself whether or not you really want to put that into the device that you're creating. And then for high-risk sites, I'm not entirely sure if we've got the kit we need in the UK to deal with high-risk sites. If you go back to the data, I keep quoting the 350 milligrams per litre and the 700 micrograms of zinc. That's an average example. But I've also got examples of road runoff having 500, 600 milligrams per litre of suspended solids in them. In fact, that device we installed in Wigan, that vortex grit separator, we took the analysis of the inflow to that vortex grit separator, and it was just a normal road in Wigan. There was nothing extraordinary about it. There weren't any huge antecedent dry weather periods to worry about, and yet we were picking up massive pollutant loads on the inflow of hundreds of milligrams per litre. So maybe for a sensitive environment, if you were discharging that into a watercourse with fish population, a migratory fish population, maybe for road runoff or industrial estate discharges, we have to start thinking bigger than we are now. So we have to start thinking about flow balancing, and then maybe grit separation, maybe then a vegetative device, but it would have to be a big vegetative device, and then possibly filtration. I've got some colleagues I work with, we're looking at the particle size of this runoff. So if you've got 25 kilograms of contaminated sediment coming off your road, is that big particles? Is that little particles? Is that a mixture of particle sizes? And there's certainly a thought now that the particles, the little tiny particles, are the ones that cause the most pollution. But they're not going to come out in a sedimentation device unless it's got really good flow rates, really low flow rates. You might need to start dosing with flocculants, or you might need to consider filtration. And we're really way away from here. We haven't got to the point, certainly in the UK, where we're looking at this level of treatment for high-risk sites. And I wonder, just to come on to the, I'm going to ask you loads of questions now. I don't know if the pollution is bad enough to justify the investment in that level of treatment. So if you were to install a treatment system that had flow balancing and then grit separation and then maybe a big pond with some treatment wetland upstream and then maybe filter material downstream in a chamber, maybe even a micro filter beyond, you're looking at, £1 million, £1.5 million per outfall. And I don't know how much we can justify investing in treating stormwater, certainly in the UK, because I don't know if the pollution is bad enough. So that discharge I showed you in that bottle going into the River Ribble, it's a huge river. So perhaps that river can cope with that discharge as it is. Or perhaps it just needs a bit of treatment. Maybe if we just treated it a little bit and took some of the contaminated sediments out, maybe that would be enough. Maybe that's all we can afford. But then if that bottle of black dirty water was going into a small stream in Cumbria where they've got a population of crayfish that they're protecting, then certainly that's not good enough. You can't start putting polyaromatic hydrocarbons and toxic metals into a watercourse that's got a protected species living in it. So then what do you do? Then do you spend £1 million putting in microfiltration? And the truth is I don't know. And that's kind of why I've asked Peter for this opportunity to talk to you guys, because you might know. We're certainly working on it. I'm just about to ask one of my modelling colleagues to consider running a model for me, looking at that pollution input from London Road into the River Ribble, and ask that question and say, well, if you've got one outfall discharging this much gunge every time it rains, can the River Ribble cope? What if you've got 5 outfalls discharging 5 times as much? Could the river cope? And can the river cope? What's the Q95 of the river? And if the Q95 of the river is fine and it can cope with that pollution, how low would the Q95 have to go before the pollution was significant? And I don't know. But we've really got to work that out. And for groundwater, it's even harder because we don't know how much pollution can you put into an infiltration device like a swale before that pollution starts to migrate down through the subsoils and then through the unsaturated zone into the groundwater. Is that okay if you do that for 50 years because your design life is 50 years? Or is that too long? Does that give the pollutants too long and give them the opportunity to go down into the groundwater? There's a massive need for more investigation into the existing SuDS schemes we've got in the UK now to try and understand this migration of pollutants. How are they getting into the environment and are we stopping them? Are we, with our SuDS devices that we've got now and perhaps with SuDS devices we design in the future, are we going to stop those pollutants getting into the environment? And I don't know. And then the other burning question, and there's lots of people working on this at the moment, particularly for roads and industrial estates, actually would it be better if we just clean the roads better and empty the gully pots more often? Because there's some evidence that road washing, not just road sweeping with sweepers we're familiar with, but road washing with water and sweepers and suction and all that sort of stuff, is that good enough? Does that take the pollutants off the road surface so they never find their way into the water environment? I don't know. I would be delighted to find out. So I just wanted to finish with just a sort of summary of the things that I really, really want you to remember. We've got to start here and we've got to do a whole lot more work on this. There's lots of you out there and you might all be doing little bits of this and you could let me know what you're up to. But please, please remember that not all stormwater runoff is equal. Some is fine. I genuinely want to, most developments that planning teams in this office look at, the runoff from them will be fine. It's residential developments, it's small primary schools, it's shopping precincts. Stormwater runoff from that will be clean enough that a couple of SuDS devices or a decent vegetative SuDS device and the water will be clean enough to discharge to the water environment. But sometimes it's not. Sometimes that stormwater will be too polluted for us to just think, a couple of SuDS devices and it's fine. We really need to start designing for high-risk sites, designing carefully to make sure that the pollution is retained. And also, really importantly, segregated polluted runoff. So keep your flow rates down. If you can get the flow rate of your polluted water down to less than 10 litres a second in a 1-in-1-year storm event, then you're going to be able to find a treatment device that can cope with that and really treat it very well. But if you go up to 150 litres per second, you're really going to start struggling to find a treatment device that can cope with that because you've got too much clean water in there mixed in with pollutants and it's just really hard for the treatment devices to cope. And then thirdly, calculate the capacity of your device to retain and to capture persistent pollutants. I'm going to get a T-shirt with that printed on it because that's really, really important. And I'm not sure we're doing that yet. It's about this finite capacity. A bioretention zone or a swale or a filter drain, they have a finite capacity to deal with persistent pollutants. And we need to understand that. We need to recognise that sometime in the future, we need to restore it. And then just somehow make sure that that replacement or regeneration goes ahead. Like I say, I'm not sure how you do that because those 2 detention basins I went to visit have clearly been forgotten about. And I'm not sure how we fix that. But there's got to be a way. And that's it. I've put my email address there. I'm happy for people to email me with comments, questions, or certainly if you know the answer to any of those questions, I'd be delighted to hear from you.
I'd like to thank you for such an interesting presentation. And there are some questions that have come through. The one that struck me is one of the delegates saying, really on board with everything that you say, totally agree with what you're saying, but are there any kind of targets that are coming through to help the consultant to convince the client, the developer, that we need to install a variety of devices, both hard and soft engineered devices, to meet those kind of standards? Have you had any comment on that?
Yeah, well, certainly there are standards available in the EQS directive. There are published standards that the water environment has to achieve. And so it's understanding what impact your SuDS device is having on the receiving water environment. So there's quite a lot of modelling to do there. But if you can hang on for the new Syria SuDS manual, there's a lot more information in there on the water quality chapter on how to work out the impact of your SuDS scheme on the water environment. And that will go a long way to doing that, helping the designers to do that work.
That was the sort of response that I sent through. And what we'll do, we'll send out a survey at the end of the presentation to everybody, and we'd really appreciate your feedback questions. It'll take probably 30 seconds to run through. It's a bit of a yes, no, and confidence levels in terms of if you're now installing a device or designing a device, how confident are you about being able to control that pollutant level loading going under the ground into the groundwater? So we'd really appreciate your feedback on that, and whether you'd appreciate further webinars along these lines to show people how to work out those loadings, etc. And we've actually run some previous webinars. Myself and Ludmilla were running water quality webinars previously, where we can actually model the loadings going through these networks and looking at the effects that these devices are having. So do fill out the question at the end.
I think the difficulty, Peter, for a lot of designers is that until you've built a development, you can't know what the pollutant load is going to be from that development. And it's a real chicken and egg thing. How do I design a SuD scheme for a pollutant load? I don't know.
Yeah.
And I think there's more need for research there, just to start giving us pollutant source data, so we can say, if I build a hospital, this is going to be the pollutant load I get off. And there's some work to be done there.
Absolutely. Experience that we have overseas, if we look in the area of Australia, they put in a percentage pollution removal requirement. So rather than saying X milligrams per litre or a loading, what they're suggesting is they want to take out 80% total suspended solids, 40% of the hydrocarbons, 40% of the phosphates. And so there's some overarching kind of targets for new developments to make sure that we're at least controlling the majority of the worst cases, even at the designs phase. So that kind of work was in C609, the earlier SuDS manual before C697. So it'll be interesting to see the chapter that comes out in the rewrite. You are involved with that one, Joe, aren't you? The rewrite on the SuDS manual.
A little. I'm helping. There are other people who are writing the chapter, but I have had some input yet.
Lovely. Okay. Well, thank you once again. I really appreciate it. A great presentation. Thoroughly enjoyed it, and thank you very much. This slide is just sticking on the fact that within the Welsh Government interim non-statutory standard, there's a whole chapter on water quality there. We do have the targets coming through the EU Water Framework Directive, really being implemented through local and regional requirements. So talk to the lead local flood authorities and talk to the Environment Agency at as early a stage as you possibly can with your developments, please, folks. Thank you, Joe. Just to thank the audience as well for tuning in and for your questions, which we'll send out the answers to after the event. Just to remind you what's coming up this month, we have colleagues over in France right now at Hydrogia. This webinar was streamed to a conference in Montpellier in France. It'll be really interesting to get the feedback from what's happening over there and how they're implementing the EU Water Framework Directive. We have some training coming up on modelling of drainage systems in June from the 15th to the 18th. And we're starting a brand new series of webinars covering drainage modelling and flood modelling. And that will all kick off very shortly. The first one is looking at producing flood risk assessments and then impact of a new development upon an existing watercourse. And that next webinar will take place on the 24th of June, covering the flood risk assessments. So have a great afternoon, folks. Thank you all for tuning in. And thank you, Joe. That was really very much appreciated. And take care.
I quite enjoyed it.
Great.
Thanks, Peter.
Take care. Bye-bye.